everyone. For today's video, we are going to solve a sample problem in Chapter 6, Gas Power Cycles, OTTO Cycles. Problem 6.2. An OTTO cycle operates on 0.1 lbm per second of air from 15 psia and 150 degree Fahrenheit at the beginning of compression. The temperature at the combustion is 5000 degree Rankine, compression ratio of 5.5, hot air standard is 1.4. So A, find V1, P2, T2, P3, V3, T4, and P4. B, compute QA, QR, and W net. And for E, corresponding HP. So first, we are going to write the given. So we have M is equals to 0.1 lbm per second, and RK is equals to 5.5, and then the K is equals to 1.4, P1 is equals to 15 psia, and T1 is equals to 150 degree Fahrenheit. So degree Fahrenheit to Rankine, we have to add 460, so we get 610 degree Fahrenheit. And for our T3 is equals to 5000 degree Rankine. So first, we are going to solve for A, 0.1. So we are going to use this formula. PV is equals to MRT. So to solve for V1, we are going to arrange this formula. So we get V1 is equals to MRT over P1. And then after that, we are going to substitute the value. So we have 0.1 lbm per second times 52.34 lb per feet squared times cubic feet per lbm times Rankine times 610 degree Rankine over 13 psia or pounds per second squared times 12 inches over 1 feet squared. So cancel the same unit, cancel LB psia. So we get V1 is equals to 1.681 cubic feet per seconds. For our point 2, we have P2 is equals to P1 times V1 over V2 times raised to K. So we have P1 is equals to P1 times RK raised to K. So we have P2 is equals to 13 psia times 5.5 raised to 1.4. So we have P2 141.4006 psia. So we are going to convert this. So we have P2 is equals to 1.4 plus 141.4006 pounds per inches times 12 inches over 1 feet squared. So we have to cancel the same unit. So we have P2 20,361.68 pound per feet squared. So for C, we are going to solve for T2. So we have T2 is equals to T1 times V1 over V2 times K I raised to K minus 1 equals T1 times RK raised to K minus 1. So we have 610 degree Rankine times 5.5 raised to 1.4 minus 1. So we have 983.9 degree Rankine minus 460. So our T2 is equals to 746.35 degree Fahrenheit. And for our V2, we are going to use this formula, V2 is equals to V1 over RK. So we have to substitute the value. So 1.681 cubic feet per second over 5.5. So our V2 is equals to 0.3056 cubic feet per second. And next for our D or point 3. So we have V3 is equals to V2 minus 0.3056 cubic feet per second. So we're going to use this formula to get the P3. So we have P3 is equals to T3 times P2 over T2. And then after that, we're going to substitute again the value. So we have 5,000 degree Rankine times 141.4006 psia over 983.9 Rankine. So cancel the same unit. So we get the P3 718.57 psia. And next, we are going to solve for F. So to solve for F, we are going to solve for T4, we are going to use this formula. T4 is equals to T3 times V3 over V4 raised to K minus 1. So we have the given 5,000 degree Rankine times the V3 1 over 5.5 raised to 1.4 minus 1. So our T4 is equals to 2,528.28 degree Rankine. And next, we are going to solve for P4. So we are going to use this formula. P4 is equals to T4 times P1 over T1. And then after that, we're going again substitute the given. So we have 2,528.28 degree Rankine times 15 psia over 610 degree Rankine. So cancel the same unit. So our P4 is equals to 62.171 pounds per square inches. So for our number 2, we have CV is equals to R over K minus 1. And then after that, we are going to substitute the given values. So we have 53.34 times 53.34 pound per feet squared times cubic feet over lbm times r over 1.4 minus 1 times 778. So for our CV, we have 0.2285 BTU per lbm times degree Rankine. So for our H, we are going to find the QA. So we have this formula. QA is equals to mCV times T3 minus T1. And then after that, we're going to substitute the value. We have 0.1 lbm per second times 0.2285 BTU per lbm times Rankine times 5,000 Rankine minus 980.9 Rankine. So we have 0.1 lbm per second times 0.2285 BTU per lbm Rankine times 4,016.1 Rankine. So cancel the same unit, cancel. So we get QA is equals to 91.77 BTU per second. So for our I, we are going to solve for QR. So we have mCV times T1 minus T4. So we have 0.1 lbm per second times 0.2285 BTU per lbm Rankine times 610 degree Rankine minus 252.8.28 degree Rankine. So we have 0.2285 1 lbm per second times 0.2285 BTU per lbm runtime times negative 1918.98 degree runtime. So we have QR is equals to negative 43.833 BTU per second. And lastly, we're going to solve for G, the W net. So we are going to use this formula. W net is equals to QA minus QR. So 91.77 BTU per second minus 43.833 BTU per second. So we have the W net 47.937 BTU per second. Next, to solve for efficiency, we have E is equals to W net over QA. So we have 47.937 BTU per second over 91.77 BTU per second. So cancel the same units. So we get 0.52 times 100%. So our efficiency is equals to 52%. And lastly, we're going to solve for W net. So W net is equals to 47.937 BTU per second times 60 seconds over 1 minute. So cancel the same unit. And over 42.4 BTU per minute times HP. So our W net is equals to 67.84 HP. That's all for today's video. Thank you for watching, guys.